Hi, grade 11. Welcome to everyone. Let's continue our recorded session. Today, we will talk about oxides. Oxides, a type of compound produced due to a reaction of element with oxygen. And we know that oxygen is very active element, okay, that can react with the most of the element give us element oxide, okay. So, most of element can burn in the presence of oxygen, give us element oxide. And we have different types of element oxide. We have metal oxide, non-metal oxide, and amorphic oxide. So what the difference between them? Let's start with the metal oxides. Some metals such as magnesium and iron can react with oxygen, give us metal oxides, okay? And the metal oxide may be known as basic oxide. What's meant by basic oxide? Basic oxide, they are metallic oxide, okay, that can dissolve in water, giving alkaline solution, okay. The alkaline solution can change red litmus paper into blue. And we have some metal oxide known as basic oxide, as magnesium oxide, because magnesium oxide can dissolve in water, give alkalis, which turns litmus solution into blue, okay. While iron oxide is known as a metal oxide, but it's not known as basic oxide because iron oxide can't dissolve in water and can't give us alkaline solution. The chemical equation in the front of you show the reaction of magnesium element with oxygen, okay? Magnesium ribbon can burn in the presence of oxygen and give us white powder known as magnesium oxide. The chemical formula of magnesium oxide, MgO, okay? Also calcium, calcium a metal, so it can react with oxygen, give us calcium oxide, okay? Magnesium oxide and calcium oxide are metal oxides, okay? Magnesium oxide can react with water, dissolve in water, give us magnesium hydroxide. The type of magnesium hydroxide is alkaline solution because it can change red litmus paper into blue. Change red litmus paper into blue. This is known as alkaline solution, okay? But some metal oxides, as iron oxide, FeO, don't dissolve in water. So, iron oxide is considered a metal oxide, but not considered a basic oxide. Second type of oxide known as non-metal oxide, okay? Non-metal oxides produced due to the reaction of non-metals as carbon, sulfur, phosphorus, nitrogen with oxygen, giving us non-metal oxides, which known as acidic oxide, okay? So what's meant by acidic oxide? They are non-metal oxides which dissolve in water, forming acidic solution, okay? Non-metal oxide dissolve in water, forming acid which turn blue litmus paper into red. This is chemical equation in front of you, show us reaction of carbon with oxygen, okay? When carbon react with oxygen, it gives us carbon dioxide, okay? When carbon dioxide added to the water, carbon dioxide dissolve in water and forming carbonic acid, okay? Which quickly separated into water and carbon dioxide, okay? Another example, sulfur is example for non-metal. Sulfur can react with oxygen, okay? Form sulfur dioxide. And by dissolving sulfur dioxide in water, it gave us sulfuric acid or sulfurous acid, okay? H2SO3. Sulfuric acid and carbonic acid known as acidic solution because they can change blue litmus paper into red, okay? The third type of oxides known as amorphic oxide, okay? Some metal oxide as aluminium oxide, Al2O3, are known as amorphic oxide. Why? Because they can react with acid as a base and also can react with base as acid, giving us salt and water. Look at the chemical equation. Aluminium oxide react with hydrochloric acid, okay? So aluminium oxide react with acid. So in this case, aluminium oxide act as a base and give us aluminium chloride. It's a salt and water. Okay, give us salt and water. In second chemical equation, aluminium oxide behaves as a basic oxide because it reacts with acid and form salt and water. Okay, and in this case, in this reaction, the second reaction, aluminium oxide behaves as acidic oxide because it reacts with a base to form salt and water. Okay, aluminium oxide can react with the sodium hydroxide. Sodium hydroxide base, okay, give us sodium aluminate, okay, this is salt, and give us also water. So aluminium oxide is a common example for amorphic oxide, a type of oxide that can react with acid as a base and also react with base as acid, giving us in two equation, salt and water. And today we will talk about oxidation number, okay, and how to calculate the oxidation number of different compound. What's meant by oxidation number or oxidation state of the element or compound? Oxidation number calculated by the total number of electrons that the atom either gains or loses or even share during a chemical formation of chemical bond with another atom. So the oxidation number could be negative value, positive value, or zero. Okay, so when we know the oxidation number, it indicates if the electrons are lost or gained. Okay, and we have different rules to calculate oxidation number. Rule number 1, the oxidation number of element in its free state and combined state equal 0. Okay, like aluminium, zinc, okay, monoatomic molecule, the oxidation number of aluminium or zinc or whatever, the type of the element equals 0. Also, diatomic molecule like hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine, okay, the oxidation number of all of these elements in its free state equal 0. Rule number 2, the oxidation number of ion, okay, the oxidation number of ion equal the sign of the ion and the number of the charges that carried by ions, okay, like sodium positive ion carry one positive charge, so the oxidation number of sodium equal positive 1. Sulfur negative ion, okay, carry two negative charges, so the oxidation number of sulfur negative 2. Okay, also rule 3, the oxidation number of radical or atomic groups, okay, like carbonate, hydroxide atomic group, phosphate, okay, the oxidation number of radical equal to the charge on the ion, okay, like the oxidation number of carbonate atomic group equal negative 2, the oxidation number of ammonium atomic group equal positive 1. The oxidation number of phosphate group that carry 3 negative charges equal negative 3. Rule number 4. Oxidation number of group 1A, which is known as alkali metal, okay, equal positive 1 because group 1A, okay, characterized by presence of one electron in their outermost energy level and tend to lose the outermost electron and change into positive ions. Okay, so the oxidation number of all metals in this group equal positive 1. The oxidation number of alkaline earth metal group 2A equal positive 2 because their outermost energy level contain 2 electrons, so they tend to lose 2 electrons during chemical reaction and change into positive ion, okay, that carry 2 positive charges. So the oxidation number of alkaline earth metal group 2A equal positive 2. And the oxidation number of halogens group 7A in table equal negative 1 because the outermost energy level contains 7 electrons, so this element tend to gain electron during chemical reaction and change into negative ions. Rule 5. The oxidation number of oxygen in compound is usually negative 2. But if the oxygen, okay, form peroxide compound, okay, in this case oxidation number equal -1. And if the oxygen is bonded to fluorine, fluorine has highest electronegativity. So in this case, the oxidation number of oxygen change into +1. Rule 6, the oxidation state of hydrogen. Hydrogen in compound usually equal +1. Again, the oxidation state of hydrogen in most of the compound equal +1. But if the hydrogen making a compound with some metal, so the oxidation of hydrogen change into -1. How to calculate the oxidation number in problems? Question number 1, calculate the oxidation number of manganese, okay? The chemical symbol of manganese, Mn, in manganese dioxide, MnO2. Okay, we know that the oxidation number of oxygen equal -2, okay? So we represent the oxidation number of manganese by X, and we have 2 atoms of oxygen, so we multiply 2 atoms of oxygen times the oxidation number of oxygen, which equal -2, and we find the solution as algebraic equation, okay? So we find that X equal 4, so oxidation number of manganese in manganese dioxide equal 4. Okay. Thank you, grade 11, for your good listening, and goodbye.